So here the power rating it is given as 7.5 kilowatt. The RPM it is 900 RPM, and the pressure intensity it is 0.07 Newton per millimeter square. These are the three entities. The coefficient of friction it is 0.25 for the clutch. So by this we know that the power rating it is 7.5 kilowatt. So it means 7.5 into 10 to the power 3 watts. The RPM it is 900 RPM. So by this we can calculate the value of omega. It is 2 pi into n divided by 60. So it becomes 2 pi into 900 divided by 60. So it comes 94.26 radian per second. So by this particular RPM we have found out the angular velocity, that is 94.26 radian per second. The intensity of pressure it is 0.07 Newton per millimeter square, and the value of coefficient of friction it is 0.25. So these are only the given entities, so by which we have to move forward. So first thing, they are asked to find out the mean radius and face width of friction lining. So mean radius and the face width of the friction lining. So let us consider, let capital R be the mean radius, and W it is the face width. So both the entities, so these are in millimeters, we have to consider. So therefore the ratio of mean radius to face width is the ratio of this R by W. So this is given, the ratio of radius to the face width as 4. So this is given as 4. So we know that the friction area of these frictional faces so we can find out this area is equal to this 2 pi into R. So it is a circular ring, so that's why 2 pi R, and along this width, so that's why it is a W. This is the thing. So once you know the area, we can find out the normal axial force acting on frictional faces. So therefore normal or axial force acting on friction faces. So therefore, the normal or the axial force we can find out it is in terms of this pressure intensity into area. So we have calculated this area A, we know the pressure intensity. So therefore, the area 2 pi r into W into pressure intensity So therefore, now we can calculate the torque by considering the uniform wear theory. Okay. So therefore, considering uniform wear. So if I consider the uniform wear, we know that torque is equal to N into mu into this load W into R. So the N stands for the number of frictional surfaces here. Mu it is the coefficient of friction. W it is the normal or the axial force, and capital R it is the radius, wind radius. So therefore, N into mu is 2 pi r into W into P. So this is the small w. If I consider this is capital R. So if you simplify, you get N into mu in bracket this 2 pi r into r divided by 4 into pressure intensity P. And again the outside bracket this particular r. Okay, so this will be pi by 2. So this simplified version into N into mu into P into r cube. So this we have written because the ratio they are given, W is equal to R by 4. So that's why we have kept the value of this W, it is in terms of R. So here as it is a single plate clutch, both the sides are active. So therefore the number of active sides are 2. So here I can write it in this form, 2 into pi by 2 into the value of mu it is 0.25 into 0.07 into r cube. So if we simplify, I'll get this value as 0.055 r cube. In terms of r cube, we will get the torque. This is the torque. The unit it will be in terms of Newton millimeter. So this we have got it by considering the uniform wear theory. Now we also know that the power transmission, it is in terms of torque into the angular velocity. So if torque into angular velocity, so we know that the power it is actually given 7.5 into 10 to the power 3. So therefore the torque we can calculate, and the angular velocity it is 94.26. So what will be the torque we have calculated here? So let it be 1. What will be the torque we are getting here? So So here we are getting the another torque, 79.56 10 to the power 3. This will be again in terms of Newton per millimeter. So we have got the second equation, equation number 2 and equation number 1. So from this equation we can calculate the value of R. So from equation 1 and 2, so we'll get the value of R cube is equal to 79.56 into 10 to the power 3 divided by 0.055 is equal to 1446.5 10 to the power 3. So it means the value of R I'll get 113 millimeter. If you take the cube root, you'll get the value of R, it is 113 millimeter. So therefore, once I got the value of R, I can calculate the value of width is 113 divided by 4, so it is 28.25 millimeter. So I got the R also, and we have got the width also. Now the second part, the inner and outer radii. So let us consider, let R1 and R2, the outer and inner radii. Now see, since the width of this particular clutch plate is equal to the difference of the outer and inner radii, so we can write, we know that, so always this W is in terms of difference of these two radii. So this difference, so already we know, we already found out, it's 28.25 millimeters. So let it be equation number 3. So also from uniform theory we know that, so if I consider the uniform also, uniform where it tends to the mean radius capital R, it is in terms of R1 plus R2 divided by 2. So you can write that's R1 plus R2 is equal to 2 times R is equal to 2 times 113. So 226 millimeters. So again I'll get one equation. So if I consider these two equations, so by equation number 3 and 4 we can calculate the value of R1 and R2. Just it's a simultaneous equation. So from equation 3 and 4, if I solve, the value of R1 will get 127.125 millimeters. This, and the value of our inner radius, it is 98.875 millimeters. Okay, that's all.